in our last video, which I'll link in the description below, we purified 10 milligrams of antibody on a tiny 1 mil column. So now imagine a situation where we have this 1 mil column, but we need to purify 150 milligrams. You know, protein A columns are very expensive. We could load more cell harvest onto the column, but in doing that, we could also miss some antibody by overloading the column. You know, we would still have to do 4 or 5 runs maybe. So instead, let's say we decide to go the safe route and do the same run we just did 15 times. Scouting is a feature of Unicorn that will make this task, running it 15 times, a snap. It's designed, Scouting, to be able to repeat the same method many times while still being able to change some variables with no input from us after we start it. I'd like to introduce you to Scouting by doing this. That is running the method we just did 15 times in a row to purify 150 milligrams, just trying to be clear there. And we'll be able to do these 15 runs overnight. So no input from us. We'll start by adjusting the method we just did in the last video. There are 2 small fixes we need to make. First, in the method, fractionation is only allowed to occur inside the elution phase. Why is a topic maybe for another time. So we'll just have to make the elution phase longer, maybe 2 CVs longer, 5 in total. So what I'm talking about is right here. Even though this is highlighted in blue, the peak fractionation ended right here. You can see the out right there. So the peak ended right there, and you can see inside the peak table, we only collected 1.8 mils. So from here to here, right? There's the waste out. You can see it a little bit more clearly right there. So let's say we want to collect something that's a little bit closer to this, but also we'll need to change the peak fractionation parameters, because even if we still made, like right now, the setting is to 100 milliabsorbance units. 100 milliabsorbance units is still going to take us out here well beyond this point. Like, we want to make a nice tighter peak so we get more concentrated antibody. To do that, we're just going to increase the peak fractionation parameters. So instead of 100, we're going to maybe do 300 or 500. All right, once we've done that, we'll turn on Scouting. So let's go to the method editor and open the method. So here's the method editor. And I went over how to find the method editor in another video. Here's the protein A method we wrote using the phase library. Okay, so hopefully this looks familiar. We're going to use the phase properties tab, and we're just going to go over to the elution phase, right? So the 2 things we need to change are the length of the phase and the peak fractionation parameters. So first off, the length of the phase is going to be 5 CVs right there. And then the peak fractionation parameters, we're still using peak fractionation, still doing 2 mil peak fractionation fractions volume. And then we want to press the peak fractionation settings button. It's set to 100. Let's go with 300 milliabsorbance units. Oh, not 300. Just 1, 2, 300.00. I'm just a stickler for that kind of stuff. Okay, 300.00. Okay, great. That's all we need to do to actually fix the method. So we'll hit save. All right, now we're going to turn on Scouting. Scouting is really easy to turn on. You just have to hit this button right here that says Scouting. And so I guess these little bars are like, oh, I want to change this variable a little bit, like to the right. I want to change this variable a little bit to the left. And so this is sort of a window within a window. And what comes up is the Scouting variables. And what we need to do is, from the variable list that we see, like when we start a method, we need to pick which ones we want to be able to possibly change with Scouting. So I always like to have the column position there, and then the amount of supernatant that I'm going to load. These just kind of give me, cell harvest that we're going to load. These 2 things sort of give me like some grounding. They kind of tell me where I'm at. But then The other thing we're going to change is how we clean the column. So we're not going to clean the column every run. We're going to clean the column every 5th run. All right, so we're going to do these 3 right here. So this is the, like these 3, I don't think they're in a row. Like one of these is the buffer, column re-equilibration. Another one is the purification agent, the guanidine hydrochloride, and the last one is the water wash. So we're just going to do these 5. Okay, and then I just want to show you how you do one cycle. So essentially 5 purifications and then a SIP, a clean in place procedure. And then, we'll be able to repeat that because I want to be able to show you something else you can do when you're starting the run. So we have our first run, and the first run we re-equilibrate the column, we CIP the column, and we water wash 3, 3, and 3. That means right now in the first run, we're going to be doing a column cleaning. We don't want to do that. We want to save that for the 5th run. So I'm just going to hit 0 here, 0, and 0. All right. So now I'm going to insert runs, right? And we're going to do 5 in total. And so I just slide this bar over. There's a limited view here. So now I'm doing 5 runs, right? Where we're emptying the loop. We're not emptying the loop with 11 mils. Remember, we're doing 10 because, otherwise we're doing 11 milligrams. We're going to use a larger super loop when we do this. So we're just going to set this to 10 each time. Okay, there we go. All right, so for the 5th run, that's when we want to do the clean in place. So here we're going to make sure it says 3, 3, oops, not 30, just 3, 3, and 3. Okay, that's it. Okay. Other than that, let's see what it looks like. Let's just open it again just to make sure everything's saved properly the way we want it. Okay, sometimes I wish it had like a save button in here or something like that. Great. So now we need to make sure we'll go through the scouting procedure in the start protocol. So we'll hit this in the start protocol and we'll click on scouting. Okay, and we're good to go. Now we're going to put the super loop onto the system. The super loop will hold all 150 mils of cell harvest that we're going to need for this scouting run. We'll take the capillary tubing that we used in the last run off, attach the super loop onto the system. It's very important that you plug the super loop in properly. The instruction booklets show you that the bottom of the super loop is plumbed into port F on the part of the injection valve, and the top of the super loop is plumbed into port E of the injection valve. Then we're going to have to run the super loop, the stopper, and the super loop up and down several times to get all of the air out of it. Then we'll load cell harvest onto it. So when the stopper's all the way at the bottom, we're going to stop the flow from the system. So we'll make that 0. All right, now we're going to change the injection valve position too, and we're going to use a new position we've never used before. We're going to do sample pump load, and I'll put the flow path of the injection valve for the sample pump load right here so you can see how it works. Execute, and we're going to use the sample pump now to run to push the sample up into the super loop. And so I'll turn it on here and you'll see it right here on the flow path. So pump, sample flow, and we're going to do 20 mils a minute just like before. Execute. So you see the solution. I'm just going right through the buffer port. You could use S1 if you wanted to, but I'm just using buffer. But it's going through here, through the sample pump, and then it's going into the injection valve, and then it's going through the loop and then out to waste. And you'll see in the video how it loads really nicely. I can't tell you how many times it took me to get this shot. I'm running at 10x speed, And you'll notice that this stopper for the super loop goes up as the bottle of cell harvest on the top of the Avant goes down. Now we're ready to start the method. So let's see here, we're gonna close out this. All right, then we're gonna go to the method navigator, right? Oh, let's go to the method editor really fast and just make sure we've saved everything. Save, all right. Control, method navigator. We're gonna start this just like normal. I just double clicked on it. Okay, so we're gonna work our way through the start protocol. The fraction collector recognizes the 96 well plate. Okay, then we're gonna see the variable list. You'll notice here column position and empty loop width, these are grayed out. That's because we can't change them here. Like we could say, you know, the fill system if we wanted to do a different volume. That's because we're going to be able to change these variables for the empty loop width and the column position in scouting. So we'll go to next. All right, so when we wrote the scouting part of the method a little while ago, we only did 5 runs. And that's because I wanted to show you in the start protocol, you can also add runs here. So I'm gonna insert one more run. All right, so I inserted it right here at position 1. So I'm just gonna add a bunch of them till we get to position 15. All right, there are now 15 rows and only the last one is sipped. So I'm gonna do 5, 10, and 15 are the places I'm going to CIP. So I'm just gonna hit 3 in each of these positions. Okay, so this moved over. There we go. All right, that's scouting. That's 15 runs, right? And then now the result name and location. I'm gonna hit next. All right, so there's one thing that's a little different about this step, is that this line, the scouting folder subdirectory, is now open. So this is what the actual name of the result will be, but this is like, the unicorn's gonna group all of these together, and so that's what the subdirectory is. And so we're going to call this grouping 150 milligram purification. Okay, and then we're going to save this in the training examples folder, like where everything else has been going for my videos. Start. All right, so now for column tracking, you can see where this would be really important for column tracking, because now we have 15 runs here, all the way down. But again, we're not tracking this column, so we're going to disable this. That only disables the first run, so we want to apply this to all the methods that are being run. So we'll hit OK now that it's disabled, and that's it. The run started. I will turn off the microphone and try to keep this active. I'm going to fast forward through this. I'm going to at least try to do the first 2 runs, so you guys can see them. And at the end, we'll review the data just really quick. One other thing I want to show you is we're going to go to the system documentation and we're going to see how long this run is going to take. So here's scouting, right? And we can go to the method information and then method duration. So it's going to take 256 minutes. So what is that, like almost 5 hours? So 4.5 hours, I think. All right. Thank you very much. Talk to you soon. So the run went overnight and there weren't any real problems, except that the last run, run 15, ran out of water before we can start it. So that's my fault. I didn't check my solution levels before we started. Still, 14 out of 15 isn't that bad. So let's take a look. First, we can see that all the files are right here. That's just because we ran it. But how you find this scouting subfolder is you open up the training folder, and then it would be in examples, and then there's going to be another file in there called 150 milligram run. So we'll open that up, and this is where the results are. So let's just take a look at the first run. When we open the file, we can see that the fraction collected at 300 milliabsorbance units, just like we wanted. So we can see here, I'm gonna open the UV baseline adjustment curve just so we can get a really good look at it. So here's around 300 milliabsorbance units, and we can see where it started and ended the collection right here, right? And then the other thing we changed was we lengthened the time of the elution phase and the volume that was able to happen. And the elution phase is bracketed by this green curve right here, which is the concentration of B we're using. And you can see that the fraction was collected entirely in that space. The peak table below here shows that we collected 1.69 mils. We'll just call it 1.7. And since this is an antibody, we can just type in the extinction coefficient that we know here, which is 1.4. Now, if you don't know how I got 1.4, or that you can do this in order to calculate the amount of antibody in here, I made another video about doing this, and I'll put in a link to it somewhere in here. I'm still kind of getting used to this. We came out with 8.69 milligrams in 1.69 mils with a concentration of 5.1 mg per mil. So we'll just call this, 8.7 mgs, which is really good. So for 14 runs, I think that works out to about 120 milligrams. Let's see here. 8.7 times 14, 121.8. Which is pretty good. Still, we were expecting 10 mgs on each run, so that's what, like 86% of what we were looking for. If we were going for optimizing this purification procedure for tons of runs, I might, instead of loading 10 mils, I might load a smaller volume so it doesn't go. It may have gone through the column, there may have been something else going on, but still, I would say 121 milligrams is pretty good for our first run. All right, so now that we've had a look at that, let's look at the whole batch of them together. So I'm gonna go to close results. I'm not gonna save the changes. Okay, so in order to do this, I'm gonna hit the shift button in order to highlight all the runs, and then I'm going to right click and open/compare curves. And sometimes this takes a second because it doesn't just load all the UV curves, it loads every curve. So here we go. You can see that all the curves are stacked up on top of each other. This is all 14 runs, one on top of the other. So this is a really good indication that we're doing something right here. It's also really boring, but that's for chromatography, that's the exciting part of it. Let's zoom in here on the tip of the peak so that we can see really that there are actually 14 runs here, right? It's pretty good, but we're really zoomed in here. So let's reset this. Okay, and then if you do something like this on your own, like, I don't know, it could be Affinity chromatography, maybe you're in 14 or 15 SCC runs together, and you could do that like watching one of my other videos. You just kind of have to turn on the scouting for it. I invite you, but still, if you do that, you have something like this, I invite you to change the views Like in the overlay section, you could look at like, having a 10% offset for these. Um, and there's a few other things you can change in here that are like really interesting. My personal favorite is the tile. I'll show that to you in just a second. But the one thing I want to, while we're here, the one thing I want to show you is you can turn on and off all the curves still. So you can turn, these are all the all the UV runs. So, I'm going to start removing some of these and you'll start to see the curves here kind of disappear a little bit. It should become more apparent the more I get rid of. The color's kind of changing of it. So anyways, all right, let's turn back on and let me show you the tile view, which I think it looks really cool. Still, like this is a nice curve to show, like for presentation purposes. And so is tile, and that's why I want to show it. Okay, here you go. I think this looks really cool. Anyways, one of my criticisms for Unicorn is that you can't take something like this and then be able to get a spreadsheet type peak table that would allow you, for every single fraction that's been collected, that would allow you to add up really quickly all of the the entire volume you've collected and all the antibody you were able to purify. Anyways, probably should end it here. We've gone on long enough. If anybody is actually still watching, maybe leave me a comment below. I'd really appreciate it. Thank you so much for watching.